Hi everyone, we welcome you again to our second minor project. This is Ujjwal Kumar, and this is our second minor project, uh, housing project. So, in this project, we start by importing all the necessary Python libraries, NumPy and Panda for data manipulation, again Matplotlib and Cpon for visualization, and the statistics model for description stats, and the scikit-learn level encoder for preparing our categorical data. So here we have already important, as you can see. And now, so we prompt the user to upload the housing data by using this code, as you can see clearly here. Further, after loading the dataset, we configure to the Panda to display all the column and set up the plot style by this code. This code set up our here this code will display all the column and set up all the plot styles. So we immediately examine the first 5 rows of the data to give an initial look to feature like price, area, bedroom, and furnace by using this code for the first 5 rows. So here the info method tell us we have 545 entries and 30 columns with 6 numericals and 7 object categories. Yes, and I'll just show you in my output. Here it is. Yes, so you can see it all here. I'm just giving you a brief data. So non-null count, we have non-null count is 545 for every column, meaning there are no missing values in this raw data set. Finally, the summary static give us measure like mean, standard deviation, and quantities for the numerical value, which is done by this code. Printf. This will give our complete summary statics, and this will find our missing column missing values. For although the initial check showed no missing values, it's good practice to handle potential issues. We first drop any exact duplicate rows. So here we find the first exact duplicate rows. So next we separate the numerical and categorical columns by this code. Here we are separating numerical and categorical columns. And now for the numerical and numerical columns, we used to mean to fill any missing values. So we used to fill any missing values here for the numerical columns. For categorical columns, we use the mode we most frequently value to fill any missing values. So we are using for the categorical calls here, and till now we have got none output. Now we tackle the 7 categorical features. We apply level encoding to convert this object type column like main, road, and furnishing status into numerical format, which is required for correlation and model analysis. So as I have concluded that if the housing is no furnished, so I have made it as 0. If it is semi furnished, 1, and if it is fully furnished, we are labeling it as 2. So for labeling we have used this code. For labeling, le is equal to label encoder. And then now we come to the our numerical feature analysis. So we are calculating the prints that describe the statistic mean, median, mode, and standard deviation for all the numerical column using the statistics model. We use this code for calculating all the things. Now we get after doing this, we get detailed statistics of each numerical column. For instance, price has mean 4.77 and a median of 4.344 million, and area has mean of 5.50 square feet and a median of 46,000 square cities. Site city 31, 32, and minimum, as you can see here. So this is our clean data set, and this is we have encoded the value for fully furnished, semi furnished, and non furnished. and here our data is completely clean, as you can see. Now we have distributing the numerical feature for everything here. Distribute This is our complete distribution of numerical feature. Now next we generate a histogram to visualize the distribution of numerical feature. The plot confirms the price and area are right skewed, a common pattern in real estate data, while features like bedroom and bathroom are more discrete and clustered. um, okay, I'll just show you. So we are using here, and now we are using we are plotting all the graphs here, and This this code df dot has display the histogram features and distribution of numerical feature. Sorry, my English is I'm not comfortable in English, so I'm so sorry. So the correlation now we move to the correlation and relationship visualization, which we are doing by SNS heat map, as you can see here. So just a second. It is not working properly. Yes. So here we can see that this code is used for the correlation heat map and pairwise heat map to the pair plot. So did this display all the correlation heat map with all the data. The pair plot provide a matrix of a scatter plot. Now, this pair plot provide a matrix of the scatter plots, and kernel display estimating allow for details visualization inspect of all pairwise relationship. So it will display all the pairwise relationship plot as if I'm showing. Just a second. Um, Sorry. So this is our pairwise data and correlation heat map. Hmm. This is, as you can see, we have mentioned all the things here: prices, area, bathroom with a correlation heat map. And let me go further. Go. Sorry. Especially, we especially focus on our two most correlated, that is price versus area. As I have already shown you in the heat map, price and area, this is our main focus. And scatter plot clearly shows a positive linear trend, confirming that as the area increases, the prices gradually increases, as you can see here. So we finally generate a count just a second. We finally generate account plots for each categorical columns here. uh, yeah, so this plot, like the one main road, confirms that most homes have access to the main roads encoded as one, and only a small number of houses in amenities like hot water heating. So cycle through the count plus is example main road, guest room, heat pumps. It display all the cycles for column. So this is our complete code for displaying all this feature. Now we have come to the conclusion part here. So this portion I have concluded all things in this portion, showing that to summarize our analysis confirms that dataset contain a 545 rows and 13 columns, including cities 57 city, um, 5736, and we successfully cleaned and encoded all the data for robust analysis. The most significant finding is the strong correlation between price and area, a key insight for any predictive modeling task. We concluded by saying we cleaned and encoded the data. So for after this, our we have after that, after doing all this procedure, we have saved all our data. So this is the code for saving our data. Now I'll repeat again in shorter format that here I have uploaded the data by df.column. So I'll just show you the output. So I have uploaded the data here, and this is the data. And then it will first, it classifies all the data, then it checks again how much rows and columns are here. As you can see, uh, first we have displayed 5 data set row, then we completely uh, take all the output, like we have seen all the entries here. And then now for the we have summary statistics here. And then we have concluded the distribution of numerical feature as I have discussed above in the code, in which our main focus is prices with area, along with along with storage, main road, guest room, basement, and all. Here we have already included a correlation heat map. As we can see, the prices increases as the area increases. And I have already cleaned the dataset, and all the alphabetical order we have changed it to the numerical values. And this is our as you can see, this is our features, and this is our correlation heat map. Finally, we have summarized all the data here. Yes, I'll just pair wise, I have done the pair wise relationship here, as you can see. So this is our pair wise relationship, in which our main factor is prices, then area, bedroom, bathroom, storage, main road, and guest room, and all. So this is my complete project based on housing data set. Thank you, everyone.